Hi, this video is going to cover section 3.2 in the geometry textbook. It's going to look at the different angle theorems, okay, when we are dealing with parallel lines. So question number one, we want to find the measure of angle 1 as well as the measure of angle 2, and we need to specify which theorem we're using. Okay. So as you can see, what I've already done is I've color-coded my lines. So the parallel lines, I've made kind of this pinkish color, and then the transversal, I've colored blue. And that's just to be consistent with what Desmos was doing in the activity that we did. All right. So here I have an obtuse angle, which measures as 110 degrees. And then I can see that angle 2 is in the same corresponding position. It's kind of in the lower right position of that intersection. Okay. So I could say that the measure of angle 2 is 110 degrees, and the reason is because these two angles are corresponding angles. Okay. Now angle 1 I can see is across from angle 2, or the technical word there is they're vertical angles, and we know that vertical angles are also congruent. Okay. So we can say that the measure of angle 1 is equal to the measure of angle 2, which we know was 110 degrees. Okay. And so that's vertical angle relationship. All right, problem number 2. Okay, kind of the same idea. So we have this angle here, this acute angle of 63 degrees. It's kind of in the lower right position of its intersection. And angle 1 is also in the lower right position. Okay. So we could conclude that the measure of angle 1 is 63 degrees. Those angles are corresponding angles. Okay. And then angle 2 is next to angle 1. Right, they're at the same intersection and they're next to each other. And so what we know is that those two angles are going to sum to 180 degrees, right? That's our linear pair relationship. So the measure of angle 2, let's see, 100, so this, let's go ahead and write 63 degrees there. 180 minus 63, I believe is 117 degrees. And so we figured that out because we knew angles 1 and 2 were a linear pair. All right, diagram number 3. So we have this somewhat obtuse angle of 95 degrees. And we can see directly across from it at that same intersection is angle number 1. Okay, that's a pair of vertical angles which are congruent. Okay, so the measure of angle 1 is going to be 95 degrees as well. And we're just using the fact that our two angles there are vertical angles. And then you'll notice that angle 2 is in the lower left position of its intersection, just like 95 degrees was in the lower left. Okay, so these two angles are corresponding and therefore they're congruent as well. So the measure of angle 2 will also be 95 degrees due to the corresponding angles there. All right, and then figure number 4. So we've got 101 degrees, that's an obtuse angle. And you can see angle 1 is across from it at the same intersection. Again, the technical name for that is vertical angles. So the measure of angle 1 is 101 degrees as well. We'll record vertical angles. Okay. And then angle 2 is also obtuse. And notice that angle 2 is in the lower right position of its intersection. 101 degrees is in the lower right position of its intersection. So we call those two angles corresponding. Okay, so the measure of angle 2 is 101 degrees. And that relationship was corresponding. Okay, so now the next couple of problems are going to combine geometry with algebra. Okay? And what I mean here is that we have some algebraic expressions that include variables and numbers, and we're going to try to solve for x, right? So the goal here is finding the value of x. All right, so let's start with what we know. We know we have an obtuse angle of 110 degrees, right? And we can see that this angle here with the algebraic expression is also obtuse. Okay. And so those two angles are going to be congruent, okay? But what relationship do they have between each other? Well, they're on opposite sides of the blue line, so that's going to be alternate. They're outside of the red line, so that's going to be exterior, right? So these two angles are congruent to each other because they are alternate exterior angles. Okay. So we could say x plus 12 equals 110. And we'll write as our reason, alternate exterior angles. Okay. And at this point, we're just going to do algebra, right? We're going to subtract 12 from both sides, and we would get x equals 98. Okay, so if we wanted to kind of write this as a semi-proof, we could write the subtraction property of equality, right? Because we subtracted the same amount from both expressions. All right, diagram number 6. So we can see 10x minus 55 degrees, that is an acute angle. And 45 degrees is also an acute angle. Right? They're going to be congruent in this diagram, but the relationship those two angles have is that they're alternate interior angles. Right? They're on opposite sides of the blue line, and they're inside of the two red lines. So we could write 10x minus 55 is equal to 45, and we'll write alternate interior angles. Okay. And then we're just going to do some algebra now. So we can add 55 to both sides. So we get 10x equals 100. So that was the addition property of equality. And then we can divide both sides by 10. And so we get x equals 10. So we use the division property of equality. Okay, go ahead and box our answer. All right, figure number 7. Let's see here. So first thing I notice is that I have two angles that are next to each other, right? And we know that they're going to sum to 180 degrees. Okay, so that's kind of we call that a linear pair. Okay, so I could write 4x plus the measure of angle 6, which I don't know yet, okay, is going to equal 180 degrees. Okay. But what I do know is that there's an acute angle over here of 52. Right? And angle 6 itself is also an acute angle. Right? And so those two angles, you can see they're in corresponding positions. They're both kind of in the upper right position of their intersection. Okay. So I can also, I should guess right here, linear pair. So I could say that the measure of angle 6 is equal to 52 degrees because of corresponding angles. Okay. And now what we can do is we can make a substitution. Okay. So we could replace the measure of angle 6 in the green equation with 52 degrees from our red equation. And so we're going to have 4x plus 52 equals 180. Substitution. I don't think I spelled it. Substitution. Okay. And then now we're just going to use algebra. So subtract 52 from both sides. And we're going to get 4x equals 128, I believe. Okay, so that was the subtraction property of equality we did there. And then we're going to divide both sides by 4. And we're going to get x equals 32. All right, 4 goes into 12 3 times, 4 goes into 8 2 times. So then that was the division property of equality. All right. So that one was a bit involved. Right, we had to use a linear pair relationship, a corresponding angle relationship. We had to do some substitution and then some algebra. All right, and then that brings us to number 8. So I'm actually going to take a different approach to number 8. I know that they're labeling this angle here as angle number 2, but let me call this angle right here angle number 1. Okay. And I don't honestly care about angle number 2 at all. Okay. So I've got this acute angle in the top left. I've got another acute angle here, and then I've got an obtuse angle there. So what I'm going to do is kind of the same idea as the last problem, right? At the bottom intersection, I have 2 angles that are next to each other. Okay, that's a linear pair. Okay. So we can say the measure of angle 1 plus 153 is equal to 180 degrees. Okay, our linear pair relationship. 2 angles next to each other at the same intersection are going to be supplementary. But remember, angle 1 was an acute angle. And then this 2x plus 3 degrees, that's also an acute angle. And those 2 angles are in corresponding positions. So they're going to be congruent to each other. So we could write that measure of angle 1 is going to equal 2x minus 3. Okay, because of corresponding angles. And then once more, we can do a substitution. Okay, take the 2x minus 3 from this red equation and substitute it into the green equation. So now we're going to have 2x minus 3 plus 153 equals 180. Okay, we can combine like terms here. So 2x plus 150 equals 180. Sorry, I forgot to write substitution. All I'm doing here is simplifying or combining like terms. Okay, we would subtract 150 from both sides, so we get 2x equals 30. So that was the subtraction property of equality. And then I ran out of room. Let's do this. Okay, so now we're going to divide both sides by 2. We get x equals 15, and that's the division property of equality. Okay, so I'm probably going into more detail than is really required on these problems. I'm trying to write them kind of in a proof format. I don't think you really need to do it. You just need to find, the directions just say find the value of x. Okay, so really you're only really required to kind of do what's here on the left-hand side, but to kind of prepare us for proof writing, I'm also writing the reasons here. Right? So you can think of this as almost like a proof where we have statements, like algebraic statements over here, and then reasons on the right. Okay, statements, reason. Statements, reasons. And then this one was a little messy, but statements here and reasons there. Okay, so although these are technically not proofs, to kind of prepare you for, future lessons, I'm trying to write it as a proof. Okay. All right, so I hope you found this video helpful, and then I'll see you guys in our Zoom meeting.